We're going to talk about Spinnaker and Kubernetes. So just real quick, I'm curious, how many people are using Spinnaker? Just don't say anything, stare forward. Yeah, one. And then who's using Kubernetes? Lots of people, great, fantastic. So we are an all-in-one HR solution. We focus on payroll, benefits, time and attendance. If you're a small, medium-sized business, around 100 to 500 employees, we can help you run your people and make sure that everybody at your company is happy and getting paid. A couple of quick facts for us. We have around 500 employees. We're about 100 plus engineers. Like most startups, we run entirely on AWS. Very polyglot shop of Go, a lot of C#, that's .NET Core, some Ruby from our Ruby on Rails monolith. We started in 2012, and we have around 160 million in funding from Sequoia and True Ventures and Matrix Partners. So we run most of our applications on Kubernetes, and Kubernetes is fantastic. We've been on it for about 2 years now. We have a variety of nodes, a variety of clusters that we have in our different environments. We're really excited about EKS to help us with some of our operational costs. But the one thing that we really couldn't figure out or have gone through a very interesting journey on is how do our engineers engage with Kubernetes and how do they deploy their applications on Kubernetes? So when you start kind of open up this Pandora's box, there's a lot of variance in there, right? We have replica sets, we have daemon sets, we have deployments, you have native pod support. How are you managing your config map and secrets? Who's setting these values? Who has access to view them? How are you managing your namespaces? Is it per team? Is it per environment? Do you have one cluster? Do you have many clusters? What's going on with permissions and RBAC, right? Are engineers actually allowed to exec into containers? That's a huge security hole that you may need to be aware of. How are you handling log management? How are you setting up auto-scaling for your pods and monitoring CPU usage? How are you dealing with port management? You know, who gets the ability to spin up an external DNS so traffic can get into your cluster? Maybe you have the dashboard set up for observability, but who's able to access or kind of control certain things? Do you want everybody to access to everything? Do you need to lock it down per team? These are huge questions that as you start leveraging Kubernetes, you really have to answer if you are in a multi-team environment or have more than a dozen engineers, right? Not anybody can just do everything, and you really need to think about how you're presenting and catering that experience. So what we really want to do is just deploy continuously to Kubernetes, right? I'm an engineer, I'm working on my application, I can containerize it, but how do I deploy that to Kubernetes so that it's actually run and used? So the first iteration of this was we had a mono repo for our manifest files. So the baseline is that if you wanted to run on something in Kubernetes, you were responsible for that manifest. We had a mono repo so that you could see all of the configurations that were available. And the SRE team was responsible to deploying this, and they just did it via kubectl. We really had no automation whatsoever. At least we had centralized management, but there was no automation. What's worse is that some of our engineers or SREs that had access to our clusters were just going in and doing a kubectl edit, right? This is great for one-off things, but then another engineer would do a deployment, overwrote what was edited, and then something would break, and they didn't even know what the right configuration is because there was no record of it. There's a lot of copy and pasta with our manifest files, right? If you look at, or you're in an organization of microservices, most of those services are going to look exactly the same from a Kubernetes standpoint, right? They're going to have a very similar configuration. They're going to have a similar baseline. And the variance is actually really small, and if 90% of the code, even if it's in a YAML file, is the same, that's a lot of noise that you have to go through for signal. What's worse is that the control of Kubernetes was designated to a single team, and that really was a painful feedback loop for developers, right? We want our engineers to develop quickly. We want them to deploy to production. That's the whole point of something like Kubernetes, to really open up that infrastructure to your engineers, and that just wasn't happening. So what did we do? The next iteration of this was to use Jenkins, right? Everybody pretty much uses Jenkins in their organization. It's very popular for CI. What we did was we used a Jenkins file, right? Standard infrastructure as code. But Jenkins files are not that groovy, right? There's a lot of kind of stuff and CRUD and code that goes into these things. Again, did not have that declarative config that we were looking for. When you have to read these or you have to manage it, it's really just run my tests, push it up to my Docker registry, deploy it to my int, promote it to my stage, promote it to my production environments. The other thing, problem with Jenkins is that we didn't really have good visibility into our pipeline, right? If you look at the Jenkins UI, it's not really catered for continuous delivery pipelines where you may want to do a manual promotion to a certain environment, right? It doesn't have features like blue-green deployments where I maybe want to have another version of my app on and running, monitoring it before I cut traffic over to it. All of these are kind of things that you have to code in Jenkins files, and there's an impedance mismatch there that just doesn't really work. People try to make this work, and it's always this very wonky homegrown experience. We also didn't have a good sense of what actually was running in production, right? There is no good way of linking a git commit to a running Docker container or know who put that there. Jenkins just does not have the UI, and it doesn't necessarily have the capabilities despite its extensive programmability and the extensions that are available to it. So going back to the drawing board, we really wanted to think, like, what did we want to achieve, right? We have automation. We do have a continuous delivery pipeline. What's not working for us? And what do we want to solve those problems? And so in looking at our inventory list, we wanted more visibility into our deployment pipeline, right? We wanted to know who is deploying and what they were deploying. We wanted to know what versions of our code were running in each environment, how long they were running in there, was there a change to our topology? We wanted much safer deployments, right? We wanted to experiment with canary deployments where maybe we were only rolling out 20% of our traffic. Maybe we were doing that blue-green deployment where we could bring up a whole new fleet of instances or pods running in our Kubernetes, cut over to that, and then if there was a problem, very easily and very quickly cut back. We wanted closer integration with our Kubernetes topology, right? We wanted the ability to easily add new Kubernetes clusters for experimentation purposes. We wanted to better represent our int and staging and production environments. The most important aspect for me is we wanted a declarative config, right? We really wanted to simplify what an engineer had to specify in order to run an application in each of our environments and promote it through the stages. The Groovy approach wasn't really working for us. JSON is a usable configuration, but it is very verbose. We wanted something very succinct and very explicit. And then the last thing is we really wanted to focus on rollbacks, right? Most outages occur when you roll out code to production. And so being able to identify that and being able to easily roll back is absolutely essential. And certainly when something does go wrong, you want to know who did it so that you could talk to that engineer to understand, is this a known issue? What are you doing about it? Is it being remediated? Can we roll back to go to a correct baseline and then figure it out to roll forward? And that's where we looked at Spinnaker. So this is a technology from Netflix that's open sourced. It's being adopted, I think, pretty widely now. You can go to the website to learn more about it. And what I want to focus on is how do we use Spinnaker, not necessarily what Spinnaker is, right? So Spinnaker is a UI. It requires configuration like most things, and I'm going to touch on why we found it beneficial and how we configured it. So this is a project dashboard for one of our teams that's related to our tax services engine. So this is a set of various microservices. The team is responsible for all of these. And by going to this project dashboard, they can easily see all of the services that they're responsible for in one place. On the left side, we have our various environments, our int staging production. This is how code makes its way up to our customer-facing users. You can easily see the services there, and you can see the git commits that are associated with those pod containers so that you know which version of your code is running in production. And then on the right-hand side is that you have your current pipeline status. So pipelines are how code moves its way through different environments. And this shows the current pipeline for all of the services that relate into this project. So right now, this team has a lot of stuff that's like sitting on the int that's waiting for a manual judgment to make its way up, whereas there's one of here, their front-end repo has gone all the way to production. So this is a very active team, and they have a good overview as to what code they're running and what state it's in. When we dig a little bit deeper, you can see for a specific project, the various builds and the state of those builds. So everything that goes to our int environment is automatically delivered there when you check in. And what we do is our engineers go through a verification process and then manually send that up to staging. So through this UI, you can easily just click a button. It's right there on the landing page saying, I, as an engineer, think everything looks good. on the integration environment. Let's go to staging so I can open this up to a wider audience before going to production. Taking it a step further, this is one of my favorite features, is that for any stage in the pipeline, you can see the last user that made this action and when they did it. So if you have a downstream service or an upstream service and you want to know, hey, my service is a little bit finicky, but I didn't change anything, let me see if anything else was changed that I could be dependent on. You can look at, use Spinnaker to find that out, and then you can see which engineer was the last person to change it so that you could talk to that engineer. Hey, I noticed that you just did a deployment 5 minutes ago. I'm getting alarms. I think that there's a regression that you need to be aware of. Let's talk about that. And this really facilitates communication across engineers, across various teams, because they go to one place, and then they can escalate further. And then finally, the last step of detail is what does a specific service look like. So these are our various Kubernetes clusters. We set these up as kind of accounts in Spinnaker world. And then we can see the green represents the actual number of pods that are running. So production has 5 pods. They're all green because we have our health checks funneling into Spinnaker. The int only has 3 pods because we don't need to run as much there. And they're also all green. But now the question is, we have Spinnaker, it's great, but now as an engineer, now I have to learn Spinnaker, right? Like, you just made me learn Jenkins, I had to learn Groovy, I wrote all of these and copied all of these files around. Now, like, I'm just learning something else. Like, what's up with that? So we wanted to make the adoption of Spinnaker very easy, and we wanted to make sure that engineers didn't have to learn all of the intricacies of Spinnaker or how to set up their apps on Spinnaker. This was something that the SRE team would provide, and we really thought about what that abstraction looks like. So we developed a tool called Pipeliner. This is open source, so you can come check it out. This is essentially a YAML declaration that maps to the Spinnaker JSON file that the Spinnaker API requires. Spinnaker doesn't have a really good config as code strategy. They do have an API, which is really fantastic. But what we wanted to do is focus on that minimal subset. We really like YAML. It's a great declarative, simple config. And we wrote this simple tool that just takes a YAML configuration, explodes that to JSON, and then we can send that JSON to the API, or you could even copy it into the UI if you wanted to do that. And the one thing that I wanted to note here that was pretty successful for our SRE team, and that I've seen a lot that you as startups should be thinking about, are these single-purpose composable tools. Pipeliner is written in Go. It is like doesn't really have a lot of lines of code. It just does one thing. But we embed this and we extend this with other of these one-off tools to really help our SRE team engage with our larger engineers in an opinionated way that makes deploying code at Namely fairly easy. I like to call it, what is the Namely platform that we're building? Another one of these one-off tools, which is not open source, but we hope to make it open source soon just because it's fairly specific to how we deliver code at Namely, is a tool called Estuary. So Estuary is glue that sits between GitHub that holds these YAML files that Pipeliner produces and Spinnaker. It uses Pipeliner to interact with Spinnaker, and what it does is that it allows our SRE team to inject standards into our pipeline. So we think of like limit quotas and request quotas that you want your manifest files or your engineering teams to set. The SRE team does this for our engineers, and we use Estuary as a way of injecting that into the Spinnaker pipeline. That Spinnaker sets the manifest file as it interacts with Kubernetes. We also can do a lot of stuff with tagging so that we can do cost accounting, where Estuary will put in tags so that we know which pods belong to which teams if we have to kind of point to a system. Engineers don't have to touch this. We don't have to submit a lot of PRs across all of our microservice repos to make this happen. This is something that the SRE team manages centrally and allows us to extremely fit into that pipeline. So how this looks is we start off with our scaffolding. Scaffolding is how we kickstart projects. We support Go and .NET on the back end, and so we have opinionated versions of what these look like. That injects a pipeline.yaml file that has our baseline template. The engineer commits that to GitHub. We have a GitHub webhook that goes to Estuary. Estuary uses Pipeliner to configure Spinnaker, and all of a sudden, an engineer has a Spinnaker deployment ready to set up that they can move right to production. On the deployment side, we have GitHub firing a webhook to Jenkins. Jenkins is what does our continuous integration. It runs our unit tests. It publishes a Docker container to our private Docker registry. And then once that pattern is over, thanks to Estuary, we call out to Spinnaker via webhook, and then Spinnaker fires or starts that pipeline that Estuary had configured, and that is an automatic deployment to our int environment. And then from the engineering side, what do they go through? They have an int environment that everything is automatically deployed to, and then we have a simple manual stage going to staging and a manual stage going to production. And then what's interesting here is that because of that estuary, one of the things that we've done as we've gone through our Kubernetes progression is if we have a new version of Kubernetes, we'll actually spin up an entire new cluster. So that we don't have to kind of damage or compromise any of our existing environments, and then we'll just deploy all of our code to that new cluster. And one of the things that we're pretty excited about is EKS. We've had some difficulty getting EKS working with Spinnaker, but I know that AWS just released like a how-to guide on how to make the IAM permissions in EKS work with Spinnaker. But one of the things that we've been able to do is inject a new EKS cluster for our stage environment. When an engineer does that manual judgment to stage, we automatically deploy that to our staging EKS cluster. So staging, which is running EKS as a separate Kubernetes cluster, is getting the same code as the old one, and then we can eventually simply rewire things so that all of a sudden we've completely adopted to EKS and not have to kind of, again, update everybody's pipeline file, right? Stage is more of a logical concept than a physical cluster concept. And that's it. I think that we have some time. I'm happy to take some questions or follow up on any items. I don't know, do we do questions? Is that a thing? Or?
You could ask questions around like, what are unforeseen challenges? What did you, oh, here you go.
Hi. If you can share, how many people in the organization that, get up in the morning and manage the Spinnaker, the deployment part of the pipeline?
Yeah, so we had really two all-star SRE engineers. I am not one of them. I am fully taking credit for their work like a true chief architect does. They really focused on adopting Spinnaker, building out the automation for deployment, doing the configuration, building out some of the tools like Pipeliner and Estuary. Now we're in a very stable spot, and most of the management actually comes in engineering engagement, right? They have a question of like, hey, my pod is stuck. What's going on there? How do I reset it? And that's kind of where we really focus on engagement, like getting those facts together. Like, you can Google and for Spinnaker how-to, but that tells you nothing about how it's running it namely. So the kind of first phase of this was really 1 quarter, us baking Spinnaker, kind of figuring out what these pipelines actually look like, looking at the various iterations of Pipeliner and Estuary. And then we had a whole roadshow where we went around to each team and we're like, this is how we're doing it, this is Spinnaker. We did deployments with everybody so they were familiar with it. And then now it's kind of more in a self-service model where the larger SRE team has those playbooks, those runbooks set up for remediation that goes in it, and we can kind of focus on other things.
Hi, I just wanted to clarify kind of the drawings that you had about the pipelines. So in the one that included Estuary, so basically you guys are monitoring for pipeline YAMLs in the GitHub repos for each project, and then Estuary is basically taking those and sending those over to Spinnaker API?
Yeah.
So what is Estuary doing? Is that converting the YAML into the API, or is that what Pipeliner does?
Yeah, so Pipeliner is what's responsible for taking a YAML file and producing JSON. That's all it does, right?
Okay.
Estuary is what's receiving the webhook from GitHub, calling out to, like reading the pipeline YAML file from the repo, injecting some more information, like we want Slack notifications, right? But we don't want every team to like have to put in Slack because they put in like the wrong name or it updates, right? So we'll inject like steps and other configuration into the pipeline file that we read from GitHub. Then we call out to Pipeliner, get the JSON, and then we call the Spinnaker API with that JSON.
what do you, and you said you have plans to open source that part of your stack as well, the estuary?
It's something that we definitely want to do. It's more of like a resource constraint thing where we took some shortcuts to actually make it happen, and the injecting isn't as nice as we want it to be. So definitely on our radar. Look out for it.
Okay, and then the second part of my question was on the next slide. And so the pipelines are listening for changes to images on your private Docker registry, and then they're executing as a result of that? Is that how it works?
No, we trigger a webhook from Jenkins to Spinnaker that starts the pipeline.
Okay.
Yeah, you could set it up so that when you push to a Docker registry, you fire Spinnaker pipelines, but we just decided on the Jenkins approach.
Is there a reason, or is just kind of like...
I think that the Docker registry was a polling mechanism, and we wanted a push-based system. We had a lot of issues. Originally with Jenkins, we were polling Jenkins, and we had a lot of issues with just the kind of polling logic in Spinnaker. And so the webhook model is something that we favor as a paradigm, and it supported it on the Jenkins side, so that's just what we used.
Thank you.
You had to be on the entire other side. I'm coming.
So in terms of like other like alternatives other than Spinnaker, have you considered other like continuous deployment tools before using Spinnaker?
Yeah.
Like as Ansible, stuff like that.
Yeah, definitely. I'm really excited about AWS Code Build. I think that like that declarative config that you get with AWS Code Build is really solid. We didn't necessarily have to replace our Jenkins infrastructure because it's fairly baked. Code Pipeline didn't have the extension points, and it didn't have that native Kubernetes integration that we were looking for, so we opted just not to use it. And then the other aspect of it was, even though that there are some other tools around there, we just felt like Spinnaker worked very well for the amount of extensibility points. Like, it was opinionated, but not so opinionated that we felt we were locking ourselves in, and we could determine how we wanted to configure it. Great. Well, thank you very much. I'm happy to talk more in person after this, and thanks for being here.